Hello all, welcome to the course on Python programming for beginners. We are in Module 11, Object-Oriented Programming, Lecture-1. In this lecture, we are going to discuss about the introduction to object-oriented programming, the features of object-oriented programming, and the overview of classes and objects, how to create a simple class and how to create objects of the class, and also memory allocation for classes and objects. So let's begin. OOP stands for Object-Oriented Programming, and it is a bottom-up approach that organizes software development around classes and objects. That means everything in object-oriented programming is organized as an object. So because of the advantages of object-oriented programming, ever since object-oriented programming paradigm has been developed, what are the languages that have evolved later on have started implementing the object-oriented programming feature. So in this object-oriented programming, objects are the building blocks for developing any software or application. Examples of object-oriented programming include C++, Java, and Python. And the key concepts which are which made the object-oriented programming so popular include class, object, abstraction, encapsulation, inheritance, and polymorphism. So we'll be discussing about classes and objects in this class, and the remaining concepts of object-oriented programming we'll discuss in the subsequent classes. In object-oriented programming, programs are divided in terms of objects rather than procedures. So whoever are familiar with procedure-oriented programming like C language, where the program is divided into several functions, whereas in case of object-oriented programming, programs are divided into objects. These objects communicate using functions. So the data of an object is not accessible to the external functions. So if we consider any object, it consists of a set of data and the functions associated with the object. So the data of an object is not accessible to the outside world. On the other hand, the functions can be accessed by other objects or outside the program. New data and functions can be easily added whenever required. So unlike in case of procedure-oriented programming, where the data flows from one function to other function, there in order to add new data, we have to make so many modifications in other functions which are accessing that data. Whereas in case of object-oriented programming, since we are restricting the access of the data, we can easily add new data whenever is required, because we need not modify other functions which are depending on this data, because we are not providing any access to the data to the outside world. The key features of object-oriented programming include classes, objects, encapsulation, inheritance, polymorphism, and abstraction. So this diagram shows all the key features of the object-oriented programming, out of which we are going to discuss specifically about the classes and objects in this class. Let us see what a class means. A class is a user-defined data structure that binds the data members and methods into a single unit. So we can consider a class as a blueprint from which you can create many objects. For example, if you consider a person as a class, so if you create a class called as person, you can create any number of persons. Similarly, if you create a class of vehicle, you can create any number of objects that belong to the vehicle class. So any number of objects can be created using a class. Once you create a class, you can create any number of objects of that class. let's see what is an object. An object is an instance of a class. That means if you consider class as a data type, you can consider object as a variable of that class. That means it is an instance of a class, which is a collection of attributes and methods. So in class, whenever we define a class, we associate certain attributes and functions to that class. And depending on the object that we create, each object can have its own attributes and associated methods. So every object has the following properties. One is identity, state, and behavior. Identity means it is the name of the object that is by which you can uniquely identify the object. So every object must be uniquely identified. So an object has attributes that represents the state of the class. For example, if you consider a class called as person, if you consider a class called as a person with the associated attributes like name and age. So if you create objects of that class, each object will have its own values for name and age. So that is called as the state of the object. For example, a person is having the name as Ram and his age is says 25. So this name Ram and age 25 are said to be the attributes of that object. Similarly, an object has methods that represents its behavior. For example, if you consider two persons, Ram and Sham, both of them can have their own behaviors. So likewise, methods of an object represents the behavior of the class. Multiple objects can be created from the same class, but they have different states and behaviors. In the previous slide, we have discussed that once you create a class, you can create any number of objects, but each object is associated with its own set of attributes and functions. Here, attributes represent the states and methods or functions represent the behavior. Let us look at an example for understanding class and object in detail. If you consider the example of a class called as person, he can be associated with certain states or attributes which include the name, gender, and profession. And the behaviors may be what is the work he is doing and what he is studying and so on. So these are called as the behaviors of a particular person. So you can create once you create the class called as person with these states and these behaviors, you can create any number of objects and each object will be having its own values for states and behaviors. For example, if you consider a person P1, which is an object of person class, the name Jessa and the sex is female and profession is engineer. So if you look at the behaviors, the object P1, she works as an engineer in ABC company and she study 10 hours a week. So these represent the behavior of an object called as P1. So Jessa, female and engineer, these represent the states of the person P1. And similarly, she works as an engineer in ABC company and she study 10 hours a week. These represent the behavior of the person P1. And we can create one more object P2 of the same class called person with the different states, with the different set of states or attributes and with a different set of behaviors. For example, person P2 is having the name John, is a male and profession is doctor, and the behaviors of the person P2 object includes he works as a doctor in XYZ hospital, which is the behavior work, and he studies 15 hours a week. So these two, though work and study are common for both the objects P1 and P2, their states are different. They have different set of behaviors and they have different set of states. Now let us see how to create a class in Python. We have to use the keyword class, and this is the syntax for creating the class. We have to start with the keyword class followed by the name of the class. And this is called as the doc string, which is enclosed in triple quotes. So within triple quotes, you can mention what is the purpose of creating the class, which is not part of the programming, but still it represents, it is like a comment which describes the you can mention what is the purpose of creating the class. So this is optional. Having a doc string at the beginning of the class is optional, but it is always suggested. And followed by that, we have a colon. And as you know, you have to follow the indentation once you define, once you write the class keyword followed by the name of the class. So whatever the set of states and behaviors, you can mention as statements. So here statement 1 up to statement n represents the states or behaviors. So here class underscore is the class underscore name is the name of the class, and doc string, it gives a brief description of creating the class, and statements represent the attributes and behaviors or methods of the class. Let us see how to create a simple class with an example. As we have seen, it should start with the keyword class followed by the name of the class. Here sample class is the name of the class. So the doc string is I am creating a new class. Here we can write any number of states and methods. Here we are not writing any methods. We are simply writing only the variables, or they are also called as the instance variables, a equal to 10 and b equal to 20. So these are nothing but the attributes of the class. That means sample class is having two attributes, a and b. Like in the previous example, we have seen name, age, name and age. They are the attributes of the person class. Similarly here also, a and b are the attributes of the sample class. And once you create the class, you can create an object of the class by using the statement x equal to sample class. So observe here, you have to use the name of the class itself. Sample class is the name of the class. So you have to use the same name here followed by the open parenthesis. So here you are creating an object whose name is x, and this object belongs to the sample class. That means it consists of all the attributes that are defined within the sample class. So now x is associated with the variable a, and x is also associated with the variable b. So if we try to print the values of a and b that correspond to the object x, you have to use the dot operator. So print x dot a prints the attribute a of the object x. Similarly, print x dot b, it prints the attribute b of the object x. Here, no matter how many objects you create, all of them are going to have the same values. A is equal to 10 and b equal to 20. That means if you create another object called as y equal to sample class, then also the object y will be associated with the attributes a and b with the values 10 and 20 only. Because we are not passing any parameters here. If you observe, we are not passing any parameters when we are creating the class. So by default, it will be assigned with the variables a equal to 10 and b equal to 20. So if we try to print x dot a and x dot b, it is going to print the values 10 and 20. So the object is created using the name of the class. that we have seen here, x equal to sample class. When we create an object of the class, it is called as instantiation. So whenever you create an object of the class, that means we have instantiated an object. And the object is called as an instance of the class. This already we have seen. Now, moving on to, so in this example, no matter how many objects you create, you can have only the values for A and B as 10 and 20 only, because you are defining the attributes within the class itself. That means you are not allowing any parameters to be passed whenever you are creating an object. So you can initialize the object with the values that are supplied by the user by using a constructor. So you can alternatively create an object with some initial values of user's choice by using a constructor. So a constructor is a special method used to create and initialize an object of a class. And like methods, constructor is also defined within the class itself. And the object creation in this case includes both object creation as well as object initialization. Let's see how to create an object and how to initialize the object in the subsequent discussion. And whenever you try to create an object internally, the new method is going to be called. So though we don't explicitly specify or explicitly call this new function, so this new is here we have a double underscore followed by new followed by double underscore. So this is a special method that will be called whenever you create an object. So we already have seen the syntax for creating the object, which is object name equal to class name, and you have to pass the list of arguments in the open parenthesis. This is how you can create the object. In the previous discussion also, we have seen how to create a class, but only difference is here we did not pass any parameters. Simply object name equal to the name of the class followed by open parenthesis. We didn't pass any parameters in this case. On the other hand, when you create an object, you can also pass the parameters in case if you are writing the constructor. So when you create an object, it internally calls the double underscore new method, which is responsible for creating the object. Then once you create the object, the next step is to initialize the values for the attributes, and that can be done by using the init method. This init method we have to write in the program along with the class definition. On the other hand, we need not explicitly write new because it is going to be invoked whenever you write the code for creating the object like this. So you can use the init method in order to initialize the object. That means you can assign the values to the attributes by using the init method. Let us see how to use this init method. For that, let us take a sample program where we are defining a class called as person. So class person. So here we are using the init method, which is the method that is used for initializing the object, which is called as the constructor. Always remember, any method including the constructor should start with the first argument should be self. You can give any other name. It need not be self. Self is not a keyword, but only thing is you have to use some variable name, and that variable name represents the current object. That means when you are creating an object, so to that object you are assigning some values. Likewise, if you create another object, let us say object 2, in that case this self becomes object 2. And if you create the third object, say object 3, in that case self becomes object 3. So the value of self depends upon what object you are using or what object you are initializing. So that should be the first parameter in any of the methods. that you define within the class. Next, followed by the list of attributes. So these are the variables that are used for storing the attributes that you are passing in the subsequent part of the code. So the init method, this is how you can define the init method, which is the constructor whose purpose is to initialize the attributes of the class. Now let's see DEF. This is for defining any function. So since init or constructor is also a function, we will be using the keyword def, followed by double underscore init, double underscore. Then we have the self followed by the list of parameters. Now, how to initialize the attributes of the object? Here we have to use self.name equal to name. That means the name of the current object has to be initialized with the name that you are passing as the parameter when you are initializing the object. Similarly, the name of gender of the current object will be initialized with the value that you are passing. Similarly, self.profession is going to be assigned with the profession value that you are passing as an argument whenever you are initializing the object. So here you can see this is how you can initialize the object or you can create the object. So here you are passing three different values. Here Radhika is the name of the object and person. So this is how you can create the object called as Radhika of the class that belongs to the class person with the attribute values as Radhika, female and faculty. So if you look at the sequence of variables here, sequence of the attributes here, it is taking name, gender and profession. So whatever the value that you are passing here as the first argument, Radhika is going to be assigned to name. Similarly, female is going to be assigned to the attribute gender. And similarly, faculty is going to be assigned to profession. So likewise, depending upon how many attributes you want to initialize, those many attributes you have to pass whenever you create an object. And in the constructor, you have to use self.name equal to name. That means the name of the current object, which is Radhika, is going to be assigned with the value Radhika. And then the gender value of the current object Radhika is going to be assigned with female value. And similarly, the profession of the object is going to be assigned with the value faculty. So this is how you can initialize the attributes of an object by using the constructor. Now let's see defining another function or another method within the same class for printing the values of the object or for printing the attributes of the object. So that is the show object. Define show. Here, since we are not passing any parameters, simply print whatever the attributes of the objects. Simply we have only one argument called as self. So the minimum number of arguments within the method of any class is 1, because we have to pass one parameter which is a self, which represents the current object. So here we are printing name, which is self.name, and gender, which is self.gender. So in order to refer to the attributes of the current object, you have to make use of self.name, self.gender, self.profession. So if you don't use self, it will give an error, because this name is now associated with the current object and that current object is referred by using self. So whenever you use the function, you have to use the name of the object dot followed by the name of the method, Radhika.show. So likewise, class methods have to be accessed by using the name of the object followed by the method name followed by if at all there are any parameters, you can pass. Since here in the show method, there are no arguments that are required. So if you run this code, you'll be getting the output like this. So here you can see the self parameter is a reference to the current instance of the class. That means it is a reference, or it refers to the current object. So in this code, we have created a class called as person with the constructor, which is defined as init, for initializing the three attributes of the class called as person. And we also have used another method for printing the attributes of the object. And outside the class, we are creating an object called as Radhika by passing the values for the attributes, which will be initialized within the constructor. And then we are printing the attributes of the object by using the name of the object followed by dot operator followed by the name of the method. Now let us look at how the memory is allocated for classes and objects in Python. So Python is dynamically, here the memory is dynamically allocated during runtime. So whenever you whenever you define a class, memory is allocated for the class. And when objects are created, then also memory will be allocated for that object separately. That means if you are creating some 5 objects, the memory will be allocated separately for each of these 5 objects. The amount of memory that is allocated for a specific object depends upon the size of the object. That means it depends upon how many attributes are part of that object and what is the size of each of the attribute. For example, we can have attributes of string type, floating point type, integer type. So depending upon how many types of how many attributes are there and what is the data type of each of the attributes, depending on that, the size of the object varies. So the amount of memory allocated depends upon the size of the object and the amount of data it contains. So Python generally implements automatic garbage collection. That means memory management is done automatically. So here memory management means creating or allocating memory for the newly created objects, or whenever the objects are not in use or whenever the objects are deleted, the memory that is allotted for that object has to be deallocated. So such memory management operations are done automatically in Python. So for that, Python uses a concept called as reference counting. So let us see what this reference counting means. With an example. So here the variable A is assigned with the value 50. So that means memory is allocated for storing the variable 50 and that memory is referenced by the variable A. That means here we are creating a variable name A, and whose memory is storing the value 50, which is of type integer. Since only one variable is referring to this object, the reference count is 1. The reference count is 1 because only A is referring to this object. And now let's see this part of the code. A is initialized to 50. So A is initialized to 50. That means the reference count is initially 1. Now B equal to A. That means we are creating another variable B with the same value, which is equal to that of A, which is 50 only. So in such a case, memory won't be allocated separately for the variable B. Instead, B will be made to point to the same object. That means now two variables A and B both are referring to the same object. So the reference count now becomes 2. So with the third statement, C equal to 50 again. So 50 is already there. So the variable C will be made to point to the same object which is storing the value 50. So after these three assignment statements, the reference count of this object becomes 3 because totally 3 variables are pointing to the or referring to the same object with the value 50. Now let us see this whether all these three objects are pointing to the same object or not by using the ID. So ID function, it prints the value of the memory of the object. So it refers to the memory where the object is being stored. So print ID of A, it is going to print the memory location where the value of A is stored. Similarly, ID of B is going to return the memory address where the value of B is being stored. Similarly, ID of C, it returns the memory address where the value of C is being stored. So if you observe the output of these three print statements, all are printing the same value for the memory. That means we have only one object that is being created in memory, which is referenced with this memory address, and all three variables A and B and C, they are referring to the same memory location. That means memory is not separately allocated for each of these objects because the value is same. So all these three variables will be referring to the same object. Now let us see whether A, B, C both all are referring to the same object or not by using one more operator called as is. So print A is B. So you can recollect the is operator is used to test if two variables refer to the same object or not. So you can check whether two variables A and B are referring to the same object or not by using A is B. So if it returns true, that means A and B are referring to the same object. Otherwise, it returns false. Similarly, B is C and C is A. We understood that all these three objects are referring to the same object. That we can programmatically check by using is operator. A is B, B is C, or C is A. So in all these three cases, it is returning true. That means all these three variables are referring to the same object. So having understood about the reference counting, let us see how the memory is reallocated. Let's say in the previous case, A, B, and C all are referring to the same object whose value is 50. Now let us say we have modified the value of A to none. That means its value is none, and B value is false. That means it is a Boolean value. So now, since we have changed the values of A and B, they no more refer to this object where the value of 50 is being stored. So it is A and B are now referring to new objects called as none and another object where the value is false. In this case, the reference count of this object, which was earlier as 3, we have seen in the previous slide, the reference count of 50 was 3. Since A and B values have been modified, now they are referring to different objects. So the reference count of this object has now changed to 1 because only one variable C is referring to this object now. So again, that you can check by using ID of A by printing the address where to which the variables A, B, and C are referring to by using ID of A, ID of B, and ID of C. So ID of A is the memory address where the value of A is being stored. So if you observe the three values, these three values are different. That means now A, B, and C are referring to different objects and the reference count of this object where the value of 50 is being stored now has become 1. Now let us see del C. So this statement, delete statement, it basically removes the object C. It removes the object C. That means C is no more now pointing to this particular object. Okay. So the value, the variable C is now not referring to this object. So in such a case, the reference count of this object is 0. Earlier it was 1 when C is pointing to this object. Now, since C is being deleted, there is no object that is referring to this, there is no variable that is referring to this object. So this reference count of this object now becomes 0. So in such a case, the memory will be freed up. Now, if you try to print ID of A, ID of B, and ID of C once again, since there are objects that are referred to by A and B, it prints the memory addresses that are pointed or referred by A and B. These are the memory addresses referred by A and B. On the other hand, ID of C, because C is now it is not pointing to any of the objects. So if you try to print ID of C, it gives an error. It says that it is a name error and name C is not defined because we have deleted the object C. That means C is no more pointing to this object. So with this, we came to the end of this lecture 01, in which we have discussed about the object-oriented programming, which is a programming paradigm with objects as the building blocks. And the key concepts of object-oriented programming include class, object, inheritance, encapsulation, abstraction, and polymorphism. And out of these concepts, we have discussed about the class and object, and the concepts of class, objects, and we have demonstrated how classes and objects are created. And we also have seen the Python memory allocation for classes and objects with the help of reference counting. So with this, we came to the end of this session, and we'll be discussing the other features of object-oriented programming in the next lecture. Thank you.